Hello, everybody. Welcome to my channel, Island Daily. My name is Dr. Eamon, and I'm an optometrist. And today we're going to learn about what is accommodation and why is it necessary. So we first need to understand how the phenomenon of accommodation is going to take place in the eye. And so this right here is a figure through which I'm going to explain it. This is the ciliary body. These right here are the suspensory ligaments. This is the lens. And this purple thing over here, right here, is the capsule. So this figure shows a lens which is in its relaxed state, which means that it is right now it is flat. Okay. So as you can see that in the relaxed state, three things are going to happen. The first is relaxed ciliary body, right? The second is flat or relaxed lens. And the third thing is constricted suspensory ligaments. Now, the most easiest thing you have to remember, the most easiest way through which I remember is that the ciliary body is directly proportional to the state of the lens and the suspensory ligaments are inversely proportional to it, which means that if the ciliary body is relaxed, this means that the lens is going to be in a relaxed state and the suspensory ligaments are going to be constricted, right? So how does it work? Right now, the ciliary body is relaxed, the lens. During accommodation, you have to remember one thing that the anterior curvature of the lens is going to change its curvature, which means that it is going to become more curved anteriorly, right? And what does it going to do? It will actually increase the power of the lens, right? By increasing the anterior curvature of the lens, it is going to increase the power of the lens, right? Now, what are the suspensory ligaments doing by being constricted? These are actually holding this capsule over right here and making the lens flat, right? So what actually happens during the active state of accommodation? During accommodation, the ciliary body is going to constrict and the anterior curvature of the lens is going to increase, right? And what else? The suspensory ligaments are going to relax. So now the tension which was being pulled by the suspensory ligaments on the lens capsule is now going to disappear, right? So what happens is this tension is going to disappear and now the lens has become more globular, right? Now there is one more question. Why isn't the posterior surface not being more curved? Why the accommodation is going to occur at the interior surface and not from the posterior surface? The answer is very simple because we have aqueous humor at the interior surface and vitreous humor at the posterior surface. And we all know the vitreous humor is a semi-solid like jelly-like structure and aqueous is basically water. So it is more easy to change the curvature interiorly instead of posteriorly. But there is one more thing, and that is that in the relaxed state, the posterior surface is more curved as compared to the anterior surface. But during accommodation, the anterior surface is obviously going to, the anterior curvature is obviously going to increase, right? So now we have understood that how the accommodation is going to occur. Let's think about why is it important? Why is our eye putting so much effort? Why does it needs to, increase its power, or why is this so much happening? Now recall the definition of an emmetropic eye, right? So it was that the parallel rays of the light coming from the infinity, the light rays are coming from the infinity, are going to focus on the retina, right? With accommodation being at rest. Now, we're going to break down this very simply. So the thing is that these parallel rays of light coming from the infinity. So the parallel rays of light are always coming from the infinity. And why is this proportion very important? We have to, understand what are these parallel rays. The parallel rays are coming and traveling in a straight path, and they are going to focus on the retina with accommodation being at rest, right? Now, what happens at this point? The power of the eye is 60 diopters. Now, what happens if the light changes its path? And why is it going to do it? So, do you remember when we were little, we used to draw sun like this, right? We were doing it because the light rays are actually divergent. They are diverging from a point source, right? But I am perceiving light rays as parallel, standing over here, because the distance between this light ray, which is going to reach me, and this light ray is so much, right? So this is the reason at a specific distance, which is 6 meters minimum, that is why we take sun and chart at 6 meters, because at that point the light rays are parallel, right? Then what happens at near? Now, if I take a subject, for example, if I take a book, right, and if I start reading it, what is it going to do? The light rays at near are going to diverge, right? Now the light rays are not parallel. They are not parallel. They are diverging. And what is this going to cause? Now, now the light rays are diverging, right? And due to this, these light rays with accommodation being at rest are going to fall behind the retina. Now my eye needs more power, so it is going to fall on the retina. The other thing is that if the eye elongates, and these light rays are going to fall on the retina, which is not practical. So the natural phenomenon is that the eye is going to change its curvature. The lens is going to change its curvature, and now the power of the eye will depend on the focal length. You know, if it is 50 centimeter, my eye is going to put accommodation of 2 diopters. Now, how did I calculate it? The formula is quite simple. D is equal to 1 over F, where I can convert this focal length into diopters. So at the distance of 75 centimeter, it is going to what? 60. And at the distance of 65 centimeters, it is going to be 1.5 diopter. You can notice how how the distance is increasing, the diopter power of the accommodated lens is also decreasing, right? So the closer it is going to go, the more the lens is going to change its shape. So the light rays can fall on the retina. So this was a video. Thank you for watching, and for the future, like my channel, subscribe to my channel, like my video, and do share it with your fellows. Thank you so much.